So in this video, I will be explaining you how to create a envelope surface like this for a skyscraper and how you can put these panels on these surfaces and also how to optimize the shape of this envelope using Galapagos. So I will be explaining this in parts. So in the first part, what I'm going to do is I have this model that is an already baked and optimized model, which also has materials in it, uh, which I have categorized here. So these materials I've categorized here. Glass 2 is, uh, yeah, I wanted to make solar panels, so I named glass 2 and created this glass tinted blue type of glass, so we can distinguish that we have a clear glass here and there's a solar panel on the top. I have created it 2 times, also concrete 2 times, but I'm using only one of these. So okay, I'll show you the rendered perspective of this model. So this is how it looks when it is rendered. So these are my green panels, which is having certain principle, and you can see there are floor slabs here, and I have splitted these parts into two. The top is having this blue color, that is the solar panels, and this is the normal facades. So okay, I'm going to explain you how to create the lofted surface with all this facade materials. So let's go to the shaded view right now. So first of all, what you require here is a curve. So this curve, you can manipulate the design of this curve. As you can see, my design has this kind of curve at the bottom, which you can see like this. So yeah, so first you need to have a curve like that. I have a rough curve here. So this curve you can manipulate the way you want. So I will manipulate it a little bit more like this. Okay, so it looks similar to this now. After manipulating this curve, what I have to do is I have to select this curve and put it into this function. So you can see now already it created a envelope surface, and also it did Ladybug analysis for this entire surface automatically because the Ladybug plugins are connected. So maybe I turn this off for now. Okay, so I will explain now entirely in parts how to manipulate this envelope surface. So first of all, this is the typical thing what we do to import a EPW file for Ladybug. So yeah, this is something we require for Ladybug, and here in the first step we took this curve, which is this bottom green color highlighted curve, and we made a linear array of this curve. So what does this mean is this curve can be multiplied into the vertical z direction So I have multiplied it 6 times, but you can only see this three curves right now because I have hidden other geometries like this. If I turn on this, you can see the top curve. So I've hidden this because I'm only manipulating this part and this part of the building. So you can see at this particular curve, the shape of the building changes. So you can do this for all the 6 parts. I can highlight it quickly. So this is the top, the second most top one, and this one. Okay, so now you can see all the curves. Okay, but I'm only manipulating some of them. So that is this one and this one. So I've highlighted only those two curves. So let's turn this off again. Okay, I've turned off the wrong one. This one is the topmost one, and okay, this I don't want to hide this one. I want to hide this one, not this one. Okay, so now I have turned off all the curves, and I'm only going to show you the curves which I'm manipulating, and those are these. That is this part, one curve, this is the second curve, and this is the third curve. So I will be only highlighting these three curves. So let's highlight this one first. Okay, so this is the first curve, and this is the second one, and this is the third one. So we are only optimizing the input values of these three curves. Okay, so in the first part, as I told you, by making this linear array, so this is the factor how long I want uh, the building. So it's in the z direction. If I increase this value, I can increase the height of the building. And with this count, I give number of curves on this surface. That is actually its number of curves on this z direction. And using these curves are multiplied onto this z axis, and then you can see here what I've done is indexing. So using indexing, I've selected the respective curves. Because this array consists of the 6 planar curve in total, I have to select one by one each curve. So I have to do indexing for that like this and put the respective indexing values like here. This is not required. So as you can see, there are total 6 values here, 0 to 5. So by putting each index value, I get a geometry, and that geometry I have used to manipulate. So what all things I'm doing here with the geometry, I'm going to show you, which is going to remain same for all the other heights. So first I take this geometry, I scale it with a factor. So if I change this value, I can change the shape of the building. Let me try it. So now you can see from the bottom the shape got changed. Okay, let me increase it again. Okay, so this is just to scale the curve, and then what I have done here is, as the first geometry, I've just scaled it. First geometry, that is the bottommost curve, I have not used it, but I've used this second curve, that is this green highlighted one. So what I tried to do here is not required like this. I will delete it and put this geometry directly here, and it's going to do the same thing. So yeah, so what I'm doing here is each geometry can be manipulated in this y direction. So if I shift this curve shifts in y direction. So as you can see, this curve got shifted in the y direction right now. But if I bring it back to 0, it remains exactly concentric to the bottommost curve. So yeah, now the next part here is I took the center of this particular geometry. For that I use this area function, and using that function I use the scale geometry, in which the center is given as input and the geometry is also given as input. So I can scale my geometry as I require. So this scaling changes the size of the curve. It increases the size. So I'm basically optimizing this part, so I get a form which has a different lofted shape. Because I'm scaling this individual curves, the lofted shape keeps on changing at these curves. So this is what I've tried to do here for each curve. This much part remains same for all other curves. Here also you can see I took the center and scaled it. Same done here as well as here and here. So this is what I've tried to do for all the 6 curves, but because I'm only using 3 of these curves to optimize my building. That is just depending on your requirement or how much you want to change the surface of the building. So there is no specific explanation why I have selected these 3 curves only, but I wanted to select these 3 curves to change the shape. So I inserted these input values in this Galapagos function. So once I have created all these curves, I can show you how these geometries look like. You can see now all the green curves on the right hand side. So you see all these green curves are being lofted together, and for that I have used this loft function. Once I loft all these curves, I take the surface and yeah, this is the surface. I've kept it separately. The same surface I've used here to make contours, and using these contours I have created an extrusion. So this is done for making the flow slabs. So this is 0.6, so it's like 600 flow slabs for this design. So using this contours you can create flow slabs, and this distance you can change. So this is 5 meter, I guess. So if I increase this, number of flow slabs get reduced, as you can see here. So I make it 5. Yeah, you can manipulate this as per your scale, how many flow slabs you want. So for this you need this contour function, which is applied on the loft, and using this distance, that is the value, how many numbers you want, you can change the number of flow slabs on this surface, inside the surface. So these contours are taken here and extruded 0.6, so you get this extrusions here. Okay, so this is understood, I guess. And yeah, these are the boundary surfaces of this contours. If you want to use it further, you can use these. So now what I have tried to do is, because I'm having this facade panel which looks like a diamond shape, I've used this diamond panels, which you can find here. Use this function which is in the lunch box, that is the paneling function here, diamond panels. So I use this function here, and I divided the number of division UV. So if I change the number of divisions, that is horizontally and vertically, the outer diamond shape keeps on changing. And once I've created the diamond panels, that is these green lines, what you can see here, I've deconstructed it so that I can select individual panel, because I wanted to give specific properties to the individual panels, which you can see in here. That is, I wanted to make this in a different color, that was green color, in the render, and this was in blue color, and this is transparent. So for that purpose I have deconstructed this faces. So after deconstructing this surface, I can select individual surfaces if I bake this part, and once I bake the individual surface, then I can select all these panels one by one and give them specific property for color or materials. So yeah, okay, so now the next part, what I've done here is I took this surface and I inserted this surface in Ladybug. So this is a typical way how you do Ladybug analysis on any surface. You can put the respective weather file in this setting, and you can get the required analysis, radiation analysis on this surface. So now I turn this on, you can see the radiation on this surface. So yeah, this is how I have completed this entire model, the shape of the model. So how did I manipulate the shape of this building to this one? Works on this Galapagos principle. So here what I've done is I took the input parameters I explained earlier. This is for the direction of the curve on y-axis. So I move this curve on the y-axis to check whether if I shift the curve, can I achieve some decrease in radiation on the surface. And also this is for scaling the curve. So to check whether if I scale the curve, whether I get any optimization in the radiation of the surface. So this thing I've applied on this 3 different curve. Here I haven't shifted this particular curve on y-axis because I wanted the bottom part to be straight, and yeah, only the top part, that is this one, as you can see on the right, and this one which I am manipulating on the y-axis. So what Galapagos does here is it keeps on changing the values of all these inputs and give us a decreased total radiation on this surface. I hope you guys understood what I tried to do. If you have any doubts, you can drop in comments. Thank you for watching the video.